All right, in this next, for example, it's going to kind of walk you through all the different steps of an experiment and ultimately ask you to draw out the diagram. So let's read the scenario. An ad for OptiGrow plant fertilizer claims that with this product you will grow juicier and tastier tomatoes. You would like to test this claim. So they're claiming that their fertilizer has juicier and tastier tomatoes, and you're going to test it. That's one thing we're going to do. And we're also wondering if you can get by with only half the dose. So we kind of have two things. One, does it work at all? And does it work at half the dose as well? So full dose and half dose. How should you set up an experiment to check out the claim? Let's assume you are able to get 24 tomato plants of the same variety from a local garden store. What is the response variable? So what is the outcome? What are we trying to measure and study and compare? And that's told to me right here. We expect the outcome is the juiciness. I have a feeling there's no E right there. I'm not really sure. Juiciness and tastiness of the tomatoes. How are you going to measure that? Well, I think that just depends. I'm assuming you could maybe measure this on some sort of a scale, quantitative scale of how juicy or tasty the tomato is. Probably with some sort of expert person who knows what juiciness and tastiness of a tomatoes would kind of be like. All right, the factor levels and the treatments. So the first things, the factor is the fertilizer. Okay, and then we're going to make different levels of the fertilizer into treatments. Now we're going to have 3 treatments here, and I know this is new for some of you, and you might be kind of confused where the third treatment has come from. But they're wondering, they want to test that this fertilizer even works in the first place. And in order, like let's say we didn't have the half dose, just ignore that for a minute. In order for us to test that this fertilizer works, we need to compare it to tomatoes who do not have this fertilizer. So you're going to have one level where they get the full fertilizer. And without that half dose, we would have absolutely nothing to compare that to. So you need to realize that one of your second levels or treatment groups is going to be either no fertilizer at all or some other fertilizer, some other mainly used fertilizer. Like if we've been using some other fertilizer all along, then let's continue to use that one so we can compare the new one to what we've been doing. This is what we would call like our control group. You need some group that's not getting what you're trying to test. So either they get no fertilizer at all, or if you've been using some other fertilizer and you're wondering if this one works better than yours, then maybe they just kind of continue to get what they were getting. And then in this example, and we don't always need this, but in this example, you're also curious if a half dose would work. So we're going to check a half dose of the new fertilizer as well. And what's going to happen here is if we see that this group is definitely tastier and juicier than this group, then that's telling me the fertilizer is working. If this group, full and half group, turns out to have about the same juiciness and tastiness, then that's telling me that I could actually just do a half dose and have the same results. If this group is significantly juicier and tastier than this group, and this one and that to that one, etc., then this works best and this might be in the middle, or maybe this doesn't work when we compare it to that. So that's why we need these two groups to just decide if the new fertilizer is working at all, and then we need the half group only because that was one of the questions posed to me in the STEM of this problem. What are the experimental units? Who are we going to conduct this experiment on? Those are the 24 tomatoes. How will you control any sources of variability that you know of? So one thing is you want to definitely make sure they have the same water, same sunlight. I'm not sure really about treatment, like care, like if you sing to them all. I know that sounds silly, but it's just something you know, singing might be silly, but it's something you want to think about. Same care, same sunlight, same water, same amount of soil. I'm just thinking here of what else could potentially affect this. So anything you can think of that could potentially affect these tomatoes' juiciness and tastiness, you definitely want to control that. How will you use replication? We're just basically, we'll split our 24 tomatoes into 2 groups of 12. Oh no, we're 3 groups. 3 groups of 8 tomatoes. 3 groups of 8 tomatoes. Describe how randomization will be accomplished. We will, well, they want you to actually, how will you actually do this randomization? So this is sort of kind of like explaining how you would do simulation. So like I will or we will number each plant 1 to 24 and use a random number generator. Well, you could say a random number table to select those numbers. Now, also explain to me what you're going to do with those numbers. So let's say I have a random number table or random number generator, and the first number it picks is 5. So what happens to tomato plant 5? So for me, my brain is processing that tomato plant 5 would go in my first treatment group. So then I'm going to say something like the first 8 selected will go into group 1, the next 8 group 2, and the remaining 8 group 3. You will be asked to do this. Explain how you will randomly assign your units, your experimental units into these groups. There's really 2 ways you can do it for the most part. You can number all the individual units in order, 1 to 24, with no regard to randomization, and then pick numbers randomly. So like on a random number table, for this one I'd have to do 2 digits at a time because there's 24 outcomes. And let's say my first 2 digits is 73. Well, I would just ignore that because that's not one of our people. But let's say 21 was picked next. That would go into group 1, and then 2. And so the first 8 would go into group 1, and then the next 8 numbers selected group 2, and so forth. Your other choice is to just line up all your tomatoes and don't number them just in order, 1, 2, 3, but instead give them numbers randomly. So like the first tomato, you might go to your number line, and that first number you find is 23. So you give that tomato number 23. And then the next tomato, next random number is 2. So that number gets 2. And the next tomato, that random number is 13. So that tomato gets 13. So you didn't order them or number them in order. You numbered them randomly. Then you could say, all right, tomatoes numbered 1 through 8 go in group 1, 9 through 16 go in group 2, and 17 through 24 group 3. So now like 1 through 8 is not the first 8 tomatoes like it would have been here. They were randomly assigned numbers. So there's 2 different ways you can do that. All right, let's make a diagram. So we have our 24 tomatoes. Those are our experimental unit. We are going to split those 24 tomatoes into 3 groups, group 1, group 2, group 3. We are going to randomly put those in those groups, so I want to make sure I write that. That is a necessity. Each group will get a treatment. So let's say this one, full dose, new fertilizer. Let's say this one's half dose, new fertilizer. And let's say this one is either the old fertilizer or no fertilizer. That just depends on what have they been doing in the past. Fertilizer. I spelled that wrong, but that's okay. All right, and then last we want to come back together and compare juiciness and tastiness of the tomatoes, and that would be a well-designed experiment. Once you've gathered your data, how will you compare the results for the treatment group? So for this one, I would probably have juiciness and tastiness measured on a quantitative scale, like 1 through 10 or something like that, 10 being most juicy or most tasty. And then I would compare the average of each group. For a quantitative variable, you want to compare averages. For categorical variables, you want to compare proportions or percent.